Hello friends, welcome to GT Science tutorial. In this video, we will start the chemical equilibrium chapter, and this is the part 1 of that chapter. And in this video, we will understand about physical and chemical equilibrium. So let's start. First of all, let's understand what chemical equilibrium actually is. So these are the necessary explanations required to understand about the chemical equilibrium. The first one is equilibrium simply means a balance. So it is the balance. Now you must have seen certain reaction of the type A giving B. Now our concern is this double-headed arrow. This represents a chemical equilibrium reaction. That means the reaction will proceed in forward direction as well as in the backward direction. Okay, so chemical equilibrium simply means it is a balance. Now the balance means when the rate of forward reaction and backward reaction is same. Now the second point says that in chemistry equilibrium is a state where the rate of forward reaction is equal to the rate of backward reaction. I've already explained this, right? So equilibrium is the state in a chemical reaction when the rate of forward reaction and backward reaction is same. That is A forming B and B forming A. This is the rate of forward reaction, rate of rate of forward reaction, and this backward reaction B to A is the rate of backward reaction RB. Okay, now the state at which this rate of forward reaction RF becomes equal to rate of backward reaction RB, that is called the chemical equilibrium. This doesn't mean the reaction stop. So the reaction will not stop. We are talking about rate of forward and backward reaction being equal, right? So by initial consideration, we might think that the reaction might stop if the opposing reaction rates are equal. But no, that does not happen. Okay, this simply means that they just happen at the same rate. The forward reaction and backward reaction happen at the same rate, but the reaction do not stop at all. So the amount of products and reactants stays constant, not necessarily equal. So whatever is the reaction or the concentration of reactant and product at the state of equilibrium, that will remain a constant value, but that will not change. Okay, and that won't be equal. That is not necessarily to be equal. Did you understand? Let me explain this one more time. Okay, suppose we have a reaction A plus B giving C plus D. Okay, there are two reactants A and B forming two products C and D, forming two products C and D. Now you can see over here A plus B, that is the two reactants are reacting to give the product C plus D. This is the rate of forward reaction. C plus D are reacting backward to form A plus B, that is the rate of backward reaction. So chemical equilibrium simply means the state at which this rate of forward reaction and rate of backward reaction is same. Rate simply means by what amount the like with change of concentration of reactant with respect to time. Okay, that is the rate. So the state at which the rate of forward reaction and rate of backward reaction is same is called chemical equilibrium. Now this doesn't mean that the reaction will stop. The reaction will not stop. Okay, so the reaction will not stop. This is the point we need to understand. Okay, so just because the rate of forward reaction backward reaction are same, the reaction will not stop, because A and B will always form C and D, will keep forming C and D, and C and D, the form C and D will keep forming A and B. Okay, so this reaction will keep on happening. The state at which the rate of forward reaction and rate of backward reaction are same is called chemical equilibrium. So simple, right? Let's move forward. Now, we need to understand about two types of equilibrium. They are the physical equilibrium and another one is the chemical equilibrium, which we will see later. Okay, so physical equilibrium occurs in physical processes. Physical equilibrium occurs in physical processes like melting, boiling, dissolving, where the substance doesn't change chemically. Okay, so physical equilibrium simply means those equilibrium in which the substance do not change. Okay, so no change in the actual substance, actual substance, no change in the actual substance. The substance will remain there, but only its physical form, only its physical form will change. Physical form simply means the state might change. Okay, so the state changes. State changes. Physical form means state changes. See, there are three examples that I have included over here. Let's understand about them. Okay, the first one is ice and water equilibrium. How do you represent ice in chemistry? H2O, and we write solid in the base, right? And water, H2O, we write liquid in the base, right? So H2O solid, that is the ice, that is the ice, and similarly H2O liquid, that is the liquid. So we can see ice and liquid or ice and water. Let's write water. That will be a more specific term. So ice and water forming an equilibrium at 0 degree Celsius. So at 0 degree Celsius, there will be an equilibrium between ice and water. Okay, this is the equilibrium. Okay, this is the example of physical equilibrium. Only the physical form of water is changing. Here solid, here liquid, but there is no change in the chemical formula, right? Similarly, the second one we can see water and vapor. How do you represent water? We have already discussed as to liquid. And how do you represent vapor? H2O, and this is gas, right? Now there will be an equilibrium existing between the liquid form of water, that is water H2O, and vapor form of water, that is gas H2O. Okay, this is water and this is vapor. This is vapor, and that happens at 100 degrees Celsius. So if we put water in at 100 degrees Celsius in a closed container, then there will be an equilibrium between water and vapor. The forward reaction is called boiling, no, evaporation that happens due to boiling, and the backward reaction is called what? Condensation condensation. And in this example, the forward process is called melting, and the backward process or reverse process is called what? Freezing freezing. This is a very simple thing, right? Similarly, the third one is the salt and salt solution equilibrium. Here we can take an example of sodium chloride, that is sodium chloride, put in water. Then this will form sodium ion, that is aqueous, plus chloride ion, that is also aqueous. So the forward reaction simply represents the dissolution. Here, the forward reaction represents dissolution of sodium chloride, and backward reaction represents the deposition of sodium chloride. So, in the forward process, sodium chloride is breaking to give sodium and chloride ion, and in the backward reaction, it is depositing to give back the solid sodium chloride ion. Now, here we can see no chemical form or no chemical form has been changed, or we can simply say no new substance has been created. The same substance is written in the two side, and there is only physical change among them. So this type of equilibrium are called physical equilibrium. Now let's move forward. Similarly, the second type of equilibrium is the chemical equilibrium. So, chemical equilibrium happens in chemical reactions and where new substances are formed. So, those equilibrium in which new substances are formed are called chemical equilibrium. We can take certain example as well, but at chemical equilibrium, what happens? Rate of forward reaction is equal to rate of backward reaction. We have already discussed about that. Similarly, concentration of reactants and products remains constant. We have already discussed about that as well. The concentration do not change, right? The rate doesn't stop. The reaction doesn't stop. It keeps going in both directions. So these are the things that happen at equilibrium. There are certain example of chemical equilibrium in which new substances are formed. The first one is Haber process, and the second one is formation of HI. So the first process is The first example is Haber process. Let me write the reaction for that. Okay, so N2 plus H2 giving ammonia and H3 ammonia. And if we want to balance it, we need to put 2 over here and 3 over here. Right now this reaction is balanced, so we can see over here 1 mole of nitrogen and 3 mole of hydrogen are reacting to form 2 mole of ammonia. This is gas, this is gas, and this is also in gaseous state. So this reaction is an example of homogeneous equilibrium reaction, but we are not talking about that. We are talking about chemical equilibrium. So as we can see, nitrogen and hydrogen are reacting to form ammonia, and this reaction is called Haber's process. Now there are certain catalysts used over here, and we don't require the complete information in this chapter, so we have not written about it. I have not written about that. Okay, now in the backward direction as well, we can see 2 mole of ammonia can form 1 mole of nitrogen and 3 mole of hydrogen gases. So this is an example of this is the Haber's process, and this is an example of chemical equilibrium in which new substances are forming. Okay, similarly formation of Hi. So this reaction is represented as H2 plus I2 giving 2Hi, 2Hi. Okay, so this is gas, this is also gas, and this is also gas. So this is also an example of a homogeneous reaction, and where we can see 1 mole of hydrogen and 1 mole of iodine are forming 2 mole of hydrogen iodide. Now this, in this reaction also new compound or new substance is being formed, right? Hydrogen and iodine are reacting to form Hi, hydrogen iodide. So this is also an example of chemical equilibrium. I hope you understood about physical and chemical equilibrium property. Now let's see what are the key features of a chemical equilibrium. So the key features of chemical equilibrium are as follows. The first one is it is dynamic, that is reactions are still happening. We have already understood that the reaction will not stop, it will keep on processing. Okay, the reactants will keep on forming product, and product will keep on forming reactant. Again that reactant will keep on forming product, and the product will keep on forming reactant if the reaction is kept at constant, the required condition, at constant required condition. Okay, similarly the another one is it is reversible. So chemical equilibrium happens, and that is a reversible process. Okay, that is products can turn back into reactants. We have already understood that. Similarly, it can be affected by temperature, pressure, and concentration. So the chemical equilibrium value can be affected by temperature, pressure, and concentration. And this law was given by a scientist called or named Le-chatelier. And we will understand about the effect of temperature, pressure, and concentration on chemical equilibrium in Le-chatelier's principal video. Okay. Now the last key feature is only possible in closed system. So chemical equilibrium only happens in closed system. If the system is open, then there won't be any chemical equilibrium. Closed system, why? So nothing escapes or enters. Now in this reaction, if you see, okay, so in this reaction, if the system is open and nitrogen and hydrogen are reacting to form ammonia, and ammonia is leaving the system, then obviously there won't be any backward reaction, right? So the necessary condition is it should be in a closed system. So I hope you understood about the basic information of chemical equilibrium, and I hope you understood about physical and chemical equilibrium. That's all in this video. If you like the video, please share this video as much as you can, and thank you for watching the video. And please don't forget to subscribe my channel so that I can make more and more videos for you. Bye bye.